So, before we start the new topic, one more sketching and solving cubic. So you said H, yeah?
So can you go to line?
Oh yeah, sorry, thanks. Okay. So, H. Y equals x cubed plus 3x squared minus 9x minus 27. That's right, Joe? Now what we're going to do is x cubed plus 3x squared minus, yeah? It's okay? Yes? Okay. So what we're going to do, hey, what's wrong? Question? No, it's okay. So what we're going to do, what are you supposed to do first? Yeah. The easiest thing to do first would be just to say, let x equal 0, and therefore y equals minus 27. So there's our first point, 0 minus 27. That's our first point. Yep. Now what are we supposed to do after this?
Like y equals 0.
Yeah, let y equal 0. So you get, therefore you want to solve x cubed plus 3x squared minus 9x minus 27 equals 0. No, I don't want to hear any talking. So after we state that we want to solve this to find the x-intercept, what's another name for the x-intercept? Come on. Roots. Our factors is a step on the way, yeah. So how do we solve this?
Yes.
Yeah, the first one is we have to guess a solution, right? Now and this is important, what we'll do is we'll get the calculator to solve it, and then we'll pretend as if we guessed the answer, okay? So what I mean by this is if I go mode 54 and type in 1, 3, minus 9, minus 27, I can see one of the answers. What's the first answer? Well, I'll let you get on your calculator. Come on, calculator.
3 minus 3.
What is it?
3 or minus 3.
Yeah, well, the first one on your calculator should be 3, isn't it? I'll wait till everybody does this now, seriously. So, Casio 991, mode 54. 53? I thought 53 was quadratic. Is it 53? Yeah, it's 54 on mine. Yes? A is 1, B is 3, C is minus 9, D is minus 27. You got that? Yeah, the first one is 3. Okay? So what we do is we pretend as if we guessed that first, okay? So for example, first guess x is 3. So I get 3 cubed plus 3 times 3 squared minus 9 times 3 minus 27, and that actually does equal 0. It's a way to save time rather than trying to guess everything, okay? But of course, you know, if one of the answers was a half, don't write down first guess is a half. Nobody guesses a half for the first guess, okay? So at least pick a whole number solution. Now, we know that 3 is a solution. So we divide in x minus 3. So let me actually highlight that. Okay. X cubed plus 3x squared minus 9x minus 27. So that would be x squared. X cubed minus 3x squared. Subtract, that's 6x squared. Minus 9x minus 27. Plus 6x. 6x squared minus 18x. Minus 9x minus 27 minus 9 finishes it. And again, we can use our quadratic formula. A equals 1, B equals 6, C equals minus 9. And if you put that in, yes, I think did I type that in right? Let me check. A is 1, B is 6, C is minus 9. So I got a decimal answer, yeah? Come on, don't let me be the only one typing this in. Yes? Now you can just go mode 53 if you like. Yes? So it's not a nice answer, right? No. So I got something like x equals, x equals minus 7.2 and x equals 1.2. Yeah? Okay. I would have thought it would have worked out nice though.
It's supposed to be minus 3.
Minus 3, yeah. That minus.
Where?
X, your x is going to be x minus 3, not plus 3.
Here?
Yeah. This is going to be x plus 3 because your x is originally x minus 3.
Oh, I'm sorry, I wrote this one down wrong.
Yeah.
Oh, great. Right, okay. Minus, plus, so, plus, thank you for spotting that. Okay, x squared plus 3x squared. So when I subtract, there's nothing left here, right?
And x minus 9. X
So it's just this carries down. Minus 9x minus 27. So it's just x squared minus 9 like that.
Yeah.
So I get minus 9x minus 27. Okay, and then here, what's the A?
1, 1.
Yeah. A equals 1, B equals 0, C equals minus 9. So the two answers here,
Minus 3 and
x equals 3 or minus 3. So, but you can see that this one here is the same as this one. So in fact there isn't 3 answers, there's really only 2 roots. Yeah. So my other roots are, or the second point is 3, 0, and then my third point is minus 3, 0, and that's it. So because it only has 2 roots, it means it must look like it just touches it at one point when it comes back down. Minus 27. And what was it? Minus 3 and 3. And is it goes up or down at the beginning? Up. So I need it to go up through that. Yeah, so it'll be like this. Touches here, then touches here, and then touches here. So there, only 2 roots. It's okay, Hassan? Yeah. So back here, that should have been minus then, okay. You have this taken down, or yes? Go down to the graph, okay. Doesn't look like a great graph, but like I said, if I asked you to sketch this, you'd get full marks because you have the x-axis labeled, the y-axis labeled, the shape is correct, it touches the x-axis only twice, and all the x-y intercepts are labeled, so all the key information is there. So it, you know, easy full marks for this one, provided you don't make a sign mistake. Okay, will we start the next topic then? Yeah. I take it that sleepy silence is yes. Yes, okay. Right, next topic, so. So far, we've seen how to solve two linear equations. One like this, one like this. And they meet once, yeah? What are the different methods we have for solving this? Firstly, the graph. So, secondly, what's the other methods we have for solving this? What are they called? What is it? Substitution, yes. Elimination, yes. Gaussian elimination. And finally, the last method we did, matrix. What we're going to look at now is how we solve this type of problem, where we have one linear and one quadratic. Firstly, when we think about the two linear problems, the two linear equations, will two lines always meet and have a solution? What do we think? Do you remember?
No.
No. What's the special situation when they don't?
Parallel.
If they're parallel. Same thing here with linear and quadratic. You're not guaranteed that they'll meet. This here meets twice. This one here meets once. Whoops. And this one here don't meet at all. So you can have two answers, one answer, or no answers. All possible. Let's have a look at an example. So for example, I give you this linear and this quadratic. And it's either going to be A, B, C, one of these possibilities. There's no way of knowing until you try to solve it, really. Of all the methods we have to solving two equations, only one method will work here. Well, anyone think they know which is the only method that works? Yeah?
Maybe if we substitute y for 0 and then add the two equations together. Solve the same thing.
Very, very close. It is substitution, yes, but there's no need to make y 0.
X equals minus 1 equals x squared minus 4x minus 1.
No, we'll go with Ahmed's original one here, the substitution. But you don't need to make it equal to 0, okay? So what you have here, look, This whole thing here equals y. This whole thing here also equals y. Therefore, if this equals y and this equals y, then they must be equal to each other. Now it's no longer a 2 equation problem, it's now a 1 equation problem. See what I did? And what was the verb for this action here? Anyone know the verb for this action? No? Equate, that's it. Like equals. The verb is equate. So I equate these. There you go, 1 equation. Now what type of equation is this one here? What does it look like? What's the name of this type of equation? Yeah, it's quadratic. I just have to take these 2 pieces to the right. So I get x squared minus 5x, and then when minus 1 comes over here, it becomes plus 1, so minus 1 plus 1 is 0. So just plus 0 equals 0. So there you go, there's the A, the B, the C. Is that okay? Okay. This gives me 2 answers here. X equals 0 or x equals 5. Yep. So I have my x. Anybody know how I can get my y? Yeah, if I just sub it back in. Now which one would be the easier of the 2 to sub in? The first one, yeah. Y is just x minus 1. So there y would just be x minus 1. So that would be minus 1, and that would be 4, yeah. So there you go. There's the first point, 0 minus 1, and the second point, 5 and 4. Question, yeah?
How do you know if the x equals 0?
Well, here I just use the quadratic formula. But if you don't want to use the quadratic formula, you can factorize. So here you have x times x minus 5 equals 0. That's one way to do it.
Okay.
Either factorize or quadratic formula.
And how do you know which y is over x?
Oh yeah, okay, so I put this here into this, and the answer I get must be paired with this one here. So they must go together. And likewise here. I use this value for x, I put it back into here, and they must be paired together as well. So this is answer 1, answer 2. Okay, write this down. Do you need me to scroll up? No, just leave it there? Okay. Okay, looks like you have that taken down. So that's a straightforward enough example. The reason it's straightforward enough is because they're both equal to y here. Oh, and by the way, the question might say give a rough sketch as well. So if I was to draw this really quickly, my first point is 0 minus 1, which would be like here. And then my second point is 5, 4, which this is very rough now, which might be like there. That's y, that's x. So I know my line must go through these points. So there goes the linear equation through those points. And I also know my quadratic must go through these points. Is my quadratic going to be a U shape or a hill shape? U shape. And it must go through these points as well. So there you go, that's the sketch of the solution, of the problem and the solution here, are the intersect points here. Please add this to your answer as well, because you're asked to sketch the answer too. Does anybody know the name of the line that touches here only once? So suppose that the answer was like this instead, that there was only one solution because the line touches the quadratic only once. Does anybody know the name of this line? Tangent line, yeah. And what about the line that cuts it twice? Like this one here. Anyone? The chord, yeah. Okay, I'm going to look at one that's more difficult now. 2a. Right, so for example, 2x minus 11y plus 54 equals 0, and then 4x squared plus xy minus 5y squared equals 0. Now, more difficult because in both equations the y is not taken out for us. Any ideas on what we should do? Yeah, but both cases? Not before that? What do you think? Yeah, change the y to the other side, but for the first, the second, or the both? Only the first one. It's too difficult for the second one. So the first thing we need to do is get the y out for the first one. Okay? So we have 2x plus 54. That's equal to 11y. Or if you want, y equals 2 over 11x plus 54 over 11. So now this is equation number 1 and this is equation number 2. Now, there's a problem, not a problem, but we just need to be careful because we're going to have fractions and big numbers here. So I'll just wait until you have this taken down, because I'll need to go to a new page in a moment. Okay, so I'll just a bit more space here. So just like before, I'll put this in here for y. So this is getting substituted in here for y. So I have, try and make enough space here, 4x squared plus xy plus xy, I lost my train of thought, 2 over 11x plus 54 over 11 minus 5y squared, which is 2 over 11x plus 54 over 11 squared equals 0. And maybe before I start expanding this, I should multiply across by a number to simplify. Does anybody know what number I should use to multiply across here? No, because inside here is 11 squared. I'll still have a fraction.
Is it plus x or minus x?
Where?
Or x squared plus x?
X squared plus here?
Yeah.
That's the plus, yes.
121.
You mean 121. I should multiply everything by 121, because what's 11 squared? 11 squared is 121. So I'll multiply everything by 121. So that would be 484 x squared, yes? Is that right? Well, what's with the low energy this morning? Come on. Yes? Okay. And then multiplying here by 121, it will be 22x squared, and then x times 54 over 11 times 121. Be 5. Oh, I won't even try. 54 times 11, 594. Thank you. 594 x, and then the 121 cancels both of these, so I'm just left with minus 5 times 2x plus 54 squared equals 0. Okay, that can be cleaned up a bit more. $506x squared plus 594x minus 5, open bracket, 4x squared, 216, is that right? Yeah, and then 54 squared plus 2916 equals 0. So I have 506x squared plus 594x minus 20x squared minus 1080x plus 14580. That's still equal to 0. Right. 506 minus 20. So 486x squared. 594 minus 1080 minus 486x plus 14580.
It's minus.
Where's minus?
1 minus 1, 4, 5, 0.
Thank you. Because of that. Now what do you think? Do you think it's likely that I deliberately chose the number so that I could divide all of these by 486? Yes. X squared minus x minus 30 equals 0. And this gives me two answers, x equals 6 or x equals minus 5. I'll just pause a minute for you to catch up there. I mean, I know it looks complicated, it looks big, it looks messy, but I'm not really doing anything complicated there. It's just lots of things that need to be added together and multiplied out. But all that's really happened is that I've just expanded this, multiplied it by 5, and then grouped terms together, and then divide by 486 to simplify it. Now that I have the x, how can I get the y? sub it in. So if I go back up to here, my first one, 2 divided by 11 times 6 plus 54 over 11, that gives me 6 as my answer. And then if I put in minus 5, 2 divided by 11 times minus 5 plus 54 over 11, that gives me 4 as the answer. So my answer is 6 and 6, or minus 5 and 4. Notice how the answer worked out as a nice number here. Not guaranteed to happen, but I feel that, you know, if this was like an exam question, it should be a nice number. Just like here, I made sure that all the answers at the back were nice whole numbers, okay? But I'm just saying it doesn't have to work out like that. Just to make it easier for you to do, I made sure the answer works out like that. Yes? Now, number 1 is quite short. So the questions I'd like you to do from number 1 is A to F. A to F. Yes? But since number 2 is longer, you can just do A to C. And I've already done A. So you just have B and C to do, really. Okay? So number 1 is A to F, and I've already done A. So it's really just B to F. And then number 2 is A to C. I've already done A, so it's really just B and C. Yes? Okay. So if you want to start those now. Don't worry, don't worry.